Hey guys, this is the lesson on combining like terms. So the success criteria are right here. I can understand that terms with exactly the same variable can be combined since the variable represents the same number. I can generate equivalent expressions by combining like terms using addition and subtraction. I can evaluate expressions by substituting a number for the given variable. The focus for this lesson is going to be success criteria number 1 and number 2. So let's take a look at some of the words that we might need to know. Variable, that's a symbol like a letter that represents a number, right? We've been using X, just like we were in our percent proportions. We could use, P or A or C, whatever it could be, doesn't matter. Just a letter that represents a number. An expression, a number sentence without an equal sign. So that could be just an expression, could be just like 5 plus 3, right? There's no equal sign. If I put equals 8, then it's an equation. So an expression is a number sentence without an equal sign, can also have a variable in it, like 5 plus x. That's an expression as well. There's no equal sign. Term, each summand of an expression in expanded form is called a term. So all this means is any item separated by a plus or a minus sign. So each part represented that's separated by a plus or minus sign in an expression is called a term. So for instance, it says 2x plus 3x plus 5. It consists of 3 terms because they're separated right here by a plus sign. 1, 2, 3. Okay, also works with subtracting or minus signs. So it could be 2x minus 3x plus 5, right? Still would be the same amount of terms. There'd be 1, 2, 3 terms. A coefficient is just the number in front of the variable. So right here, 8x, it's the number in front of the variable. So the number 8 is called the coefficient of the term 8x. Up here, it would be 2. So that would be the coefficient. Right here, it would be 3. So that's just all that means. So those are words that you might hear me using throughout the lesson. Okay, so what we're going to be doing is learning how to simplify expressions by combining like terms. So if we go back to that success criteria, I understand that terms with exactly the same variable can be combined since the variable represents the same number. So this x right here, this represents the same number. We don't know what that number is, but it represents the same number. So let's rewrite that. So we're going to do 5x plus 3x. Well, it wants us to simplify this expression, but let's learn how to do that. So 5x, 5 times x, well, all that means is that I have 5 x's. I have x plus x plus x plus x plus x, right? 1, 2, 3, 4, 5. And I also have 3 x's plus x plus x plus x. So I can combine all these x's because they're just x's. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I can combine all of these together since they're the same variable and just say, well, I have 8 x's. Right? So instead of rewriting it every time, I can just look at the coefficients of the numbers, or of the variables, I'm sorry, the coefficient of the x, and I can see that if I just add 5 plus 3, I get 8. So using what we know about multiplication, we can simplify this expression by just adding the coefficients. So let's try the second one. 5x minus 3x. Well, the same is true here. I could rewrite and say I have 5 x's, and I'm going to take away 3 of those x's. I could do just like we did with negatives. I could say, well, it's like 5x plus 3 negative x's, so negative, negative, negative. But rather than rewriting that all out, I'm just going to take the coefficients. Make sure I check my sign here. And I'm just going to 5 minus 3 equals 2. And my variable is x. Okay? Remembering that x can stand for anything. Sometimes you'll hear me say, I just use apples for some reason. That's just what I say. So I say, okay, I have 5 apples minus 3 apples. How many apples do I have? I have 2 apples. And what's that's getting me to do is just think about, okay, I have a term here that's connected to this coefficient. And so I can't subtract, I can't add without including that coefficient or that variable. So 5x minus 3x equals 2x. Okay, so this one says find the sum of 2x plus 1 and 5x. So we're going to combine these 3 terms and see what happens. 2x plus 1 plus 5x. Well, I have to look and see what terms are the same. Because if I go back to that success criteria, I can only combine terms with exactly the same variable. So if I look, I have a 2x plus 1 plus 5x. Well, I can see that this 2x and this 5x have the same variable. So using what I know, I can combine 2 and 5. I can combine those coefficients and get 7x. And then I have this 1 here that isn't related. So I have to just bring down that 1. And this is as simple as we can make this expression. So we simplified it from 3 terms to 2 terms. And these terms do not have the same variable. In fact, this one doesn't have a variable at all. Right? So it's like I have 7 apples plus 1 something. Right? I can't combine that and say I have 8 apples. So I have to be okay with this as my answer. So I have 2 terms, and that is a perfectly acceptable answer. It does not need to be simplified anymore. The next one. So now I'm going to write these 2 out. So negative 3a plus 2 plus 5a minus 3. Okay, so what I like to do, and since you guys have all the tools on Kami and everything here, is I like to circle things in the same color that are the same terms. So I'll use red, and I'm going to find all of the ones that have A. So I have negative 3A. I have positive 5A. Notice how I'm circling this as well. It's going to be important, especially when we get into like the negative numbers and positive numbers. And then I'll use blue. I have positive 2, and I have negative 3 or minus 3. So now I have to remember what we did at the beginning of the year with adding and subtracting integers. Well, I have negative 3 plus 5. Well, I can actually use, apples because it's an A. So say, okay, I owed somebody 3 apples. I got 5 more. So if I got 3 of those away, how many are left? Well, there should be 2. I'm going to also just remember I can use my pluses and minuses. So I'm going to go off to the side and make sure. So I have 3 negatives, 1, 2, 3, and I have 5 positives, 1, 2, 3, 4, 5. These create 0 pairs and become 0, so I'm left with positive 2. Hopefully that kind of rings some bells. So I'm left with 2A. Same over here. I have positive 2 and 3 negatives. How many are left? Negative 1. So I could either do minus 1 or I can do 2A plus negative 1. If you guys kind of remember that, right? Subtracting is adding the opposite. Hopefully you remember that from the beginning of the year. And there is nothing more I can do on this one. Both of these answers are perfectly correct. And they're both only 2 terms. Right? One is 2A and the other one is 1. And this is 2A and negative 1, but the operation is just changed. And that's as simple as I can get it. When I'm multiplying, I'm just creating different groups. And multiplying things doesn't create a separate term. So some people would get confused here and say, well, I can't multiply these because it's not x and this isn't 3x. But when I multiply, so 2x times 3, do you see any adding or subtracting in this expression? It should say no, there's no plus or there's no minus. So what this means is it's only one term, and I can do and combine, not really combine, but I can simplify this term even more. So it's not multiple numbers here. So this means I have 3 groups of 2x's. So I have 2x plus 2x plus 2x. Well, this is what I just did. I add my coefficients, 2 plus 2 plus 2. And I have to keep the variable, so I have 6 x's. Well, what did I really just do? I multiplied the coefficient by this number. So when I find the product of a term, I can just multiply everything in that term and combine it into a single thing, a single term. Right? So this one is 6x. That's what we just did. So what if I do this one? 4y times 5. Well, this is 5 groups of 4y. 4y plus 4y plus 4y plus 4y plus 4y. And I don't want to do that every time. So I'm just remembering, okay, I can just do 5 times 4, which is going to get me to 20y. So we have 6x, 20y. I'm going to skip this c for a second, and we're going to use these terms. So 6x, this is what we just found, 6x plus 20y. Now, I've gotten to here. Can I combine anything? Is there any like terms? Well, earlier today, I got some people saying, well, it's 26xy, but we cannot combine terms that are not exactly the same. Remember, going back to that first slide, I understand that terms with exactly the same variable. Is x the same as y? No. So I can only combine the x's and the y's separately. So I cannot put those together. So it's saying like I have 6 apples and 20 oranges. I can't say I have 26 apples. Or 6 apples plus 20 oranges equals 26 oranges. Doesn't make sense. So I have to keep those variables the same. So this is as simplified as this expression can be. So I did D first because we had already found the pieces. Let's go back to C. I have 4 times 2 times Z. People get confused, say, can't do it. I can do 8, but I can't combine it with Z. And then some people I saw do this earlier, plus Z, but I don't know what was going on there. This is one term. So I can simplify and multiply these all together because it's just one term. So I just go 4 times 2, 8. 8 times Z is just 8Z. So I'm going to stop there. There's a few more slides that we went over in class, but the video is already probably pretty long. And I just want to make sure that we can at least do these two things. So I can understand terms that with exactly the same variable. So x's and x's, y's and y's, a's and a's can be combined since the variable represents the same number. And then I can generate equivalent expressions by combining like terms using addition and subtraction. Well, that's what we were doing on those examples. And then tomorrow we will be doing number 3. So hopefully if you missed out on today, this video helps kind of catch you up. And you can always email me with any questions.